our NS Data YouTube channel. If you like the video, please don't forget to like and subscribe to our channel. So today we'll look at vectors. We'll look at vectors in physics. Now, when we talk about vectors, we must know that when we have vectors, sometimes we might also have scalars. Now, to just define, when we are talking about scalars, we are talking about units which only have magnitude. So the keyword is magnitude. Now, apart from that, when it comes to vectors, we are dealing with those which have both magnitude, the magnitude and the direction. The magnitude and the direction. In this case, we are going to give examples of vectors and the examples of scalar. Now, when we talk about vectors, remember we said they have both the direction and the magnitude. So the first example that you can give is force. Force has got both magnitude and the direction. Then apart from force, we can also give an example of displacement. Displacement. Now, from the word displacement, we find that displacement is defined as the change of position in a specific direction. Then apart from that, we can also look at velocity. We can talk about velocity. Apart from velocity, we also have acceleration. Then acceleration. Then coming to scalar quantities, we can talk about temperature. We can look at temperature. Temperature has only magnitude without any direction. Then apart from that, we can look at distance. Distance, we have got distance here. Then apart from distance, we can also look at speed. We can also look at speed. So all these that I've just given here on the board are scalar quantities. Then remember, today we are only focusing on vectors. So there is no need of you knowing these scalars. So let us focus on vectors. Okay, now under vectors, since we said the most important thing is the magnitude and the direction. Now, under direction, you find that this direction is usually expressed as an angle, in degrees, as an angle in degrees. Now, let us give an example of a force. Let us assume that we have got a force in this direction labeled F. Now, for us to know the magnitude of this force, it is really important that we know that there is a direction. Now, let us assume that there is an angle here which is theta. An angle theta. Now, from what we have here, it is really important to understand that this can be obtained by recognizing the presence of the x or y plane. Now, how can we come up with an x or y plane? It is like this. So you have your y-axis here, you label it as 1, then this one as the x-axis. Now, you can able to see that we have formed our x or y plane. Then apart from that, since we want to drive out what are called the components, it is very important to break down this force into components. What are those components? We have x component and the y component. Now, how do we go about? You find that, let us assume that there is a line here, which is parallel to this line. of y-axis. We assume this line, since it is parallel to y-axis, as y. Then we also have this line which is forming the base as x. We can able to see that we have formed a 90-degree angle here. Now, after forming a 90-degree angle here, it is really important that we recognize the presence of what is called SOHCAHTOA. SOHCAHTOA. Now, we know under SOHCAHTOA, it is really important to recognize S as a sine, then this O as opposite, this H hypotenuse, this C as cos, this one as tan. Now, remember we have got theta here, so we're going to say this is sine theta, which is equal to opposite over hypotenuse. Opposite over hypotenuse. In this case, when we come to our example here, we find that here is our theta, then what is our opposite? We find that we can see here that y is the opposite. Therefore, we can say sine theta is equal to opposite, which is y over the hypotenuse. In this case, our hypotenuse is f, so we'll put the f there. Now, we want to make this y the subject of the formula to make the first equation of y component. Next, we are going to cross multiply. So you find that 1 times y is y, which is equal to sine theta multiplied by force. It will be force sine theta. So we assume this equation as the first equation in our y-axis or y component. Next, we will look for the equation in x component. But how can we go about? Let's say we have got cos. So we know cos theta will be equal to the adjacent. Looking at the example that we have here, our adjacent is x, so is equal to x over hypotenuse, which is the force. We make x the subject of the formula. We introduce 1 here, we cross multiply. X will be equal to force cos theta. This is the second equation. This is the second equation. Then from there, remember, we also have got force here. Now, how can we deal with force? Simple. We must know that there is what is called Pythagoras theorem. But before we come to that one, let us deal with tan. So, tan, according to what we have here, it is tan theta, which is equal to the opposite, which is 1, divided by the adjacent, which is x. We make theta the subject of the formula, since we have got y component and x component already there. So for us to make theta the subject of the formula, what we are going to do, we will multiply this part with tan inverse and this part with the tan inverse. So we will say this is tan inverse. We put this in brackets, and the tan inverse this side. We put these in brackets. So you find that this tan and this tan will be what? Will cancel. Then we're going to remain with theta, which is equal to the tan inverse of y over x as our third equation. So this is our first equation, second equation. This one is our third equation. So we want to find the magnitude of this force. Now, what are we going to do? It is really simple. Let us remember that if we have got a right-angled triangle like this one, right-angled triangle like this one, assuming that this is A, this is B, then this one is C. Then we also have got a theta here. In this case, according to Pythagoras theorem, which says that the square of the hypotenuse, which is c squared, is equal to the sum of the square of A and the square of B. In this case, we can see that A is the adjacent and B is the opposite. This is what is called Pythagoras theorem. Now, so we replace c squared by 4c squared, then A, which is x squared, then plus B, in this case our B is y squared, so y squared. So this is the equation, but remember we only want this force. So if we want this force only, then we need to get rid of this square. But what are we going to do? Simple. We know that we have got force squared, which is equal to the square of x plus the square of y. We introduce a square root on both sides, where this and this square will cancel. Then we will remain with f is equal to the square root of the sum of the square of the opposite, or this is the adjacent, and the opposite, like this. This is our fourth equation. So for today's video, we'll just end here. The next video, we are going to talk about a number of examples and so many things that we have to understand under vectors. Therefore, please like and subscribe to our NS Data YouTube channel.